Assignment 1 for course unit computer organization and architecture. And my name is Kukunda Stacy. Registration number 23 stroke U stroke 10315 stroke EBE. The topic was history and development of computers over the years till today. The first generation computers. The first generation computers were developed from 1940 to 1955. They operated on vacuum tubes for circuitry, and for memory they used magnetic drums. So the famous first generation computer was the IAS computer. Then the main components of the IAS computer were main memory, control unit, input output, and ALU, which is the arithmetic logic unit. The main memory. Then for the uses of the parts of the IAS computer, the main memory was used stores both data and instructions. Then the arithmetic logic unit was capable of operating binary data. Then the control unit interprets instructions in memory and causes them to be executed. Then for the input and output, it's for inputting and outputting data. It's a process in which it helps to process the data and ensure that it's output as information. Then we go to the second generation computers. Through the late 1950s and 1960s, these second generation computers featured circuit boards filled with individual transistors. As the generation, from generation to generation, they keep on, the developers keep on improving on the efficiency and the size and the content of each computer. So the second generation computer, which used individual transistors, the transistors were smaller, cheaper, and generated less heat than the vacuum tubes, as they could also be used to construct computers and help them run smoothly. It saw the introduction. The second generation computers, which used transistors, saw the introduction of more complex arithmetic logic units, control units, use of high-level programming languages, and provision of system software. Then for the third generation computers, these functioned from 1965 to 1971. Through that time, then these computers mainly upgraded from individual transistors to integrated circuits instead of using vacuum tubes to construct the computers or individual transistors to construct the computers. These ones used integrated circuits. Even today we use integrated circuits, but we'll get to that. And the features were reliability, lesser production of heat, low maintenance, reduction in size, less consumption of power, high level language was used, use of integrated circuits, faster, more efficient multi-programming operating systems were supported. On the part of reliability, it was reliable in form of getting the work done more quickly and more efficiently. Then lesser production of heat, as transistors were used to give off more heat, and it would damage the internal system of the computer. So lesser production of heat was considered here while using integrated circuits. Then for low maintenance, in while using the integrated circuits, they need low maintenance. Probably they would service them more often than what we have right now. Then reduction in size, as the first generation computers were very huge, okay, for now. Then compared to now, they are really less and smaller. Then the most famous one, I think, was an IBM 7094. Then they also used microelectronics. Microelectronics are small electronics, okay, which is also known as small computers. They were formed due to the persistent and continuous trend of reducing the size of digital electronic circuits. As we've said, through the years, they aim at reducing the size of computers to make them more efficient and more portable to do our daily services and daily work in our daily lives. Then the basic elements of digital computer and performing data storage, movement, processing, and control function. Then there are two fundamental types of computers required in these microelectronics. These are gates, a gate and a memory cell. A gate is a device which implements Boolean or logical functions. In short, they control the flow of data within the parts of a computer. Then a memory cell is a device that can store 1 bit of data. 1 bit is equal to 8 bytes. So assigning them to the 4 functions of a computer, of data storage, data processing, data movement, and control. The memory cells are in charge of carrying out data storage, and it also helps the gate hand in hand to control the flow of data within the computer. Then the data processing is provided by the gates, and the data movement from one cell to another, from memory to memory, is through the gates. Then for the later generation of computers, these still used integrated circuits in the construction of the computers. But as we had said before, they keep on reducing the sizes to make them more portable and more equipped to use in our day-to-day lives. There has been a number of later generations based on the advance in integrated circuit technology. As we had said before, they still use integrated circuits from the 3rd generation till now, but they keep on increasing the technology and advancing the technology of these integrated circuits. With the introduction of large-scale integration, which is LSI, more than 1,000 components can be placed on a single integrated circuit chip. Then very large integration achieved more than 10,000 components per chip, while current ultra large scale integration can contain more than 1 billion components. Then the semiconductor memory. This is the main memory element of a microcomputer-based system and is used to store programs and data. The main memory elements are nothing but semiconductor devices that store codes and information permanently. It is directly accessible by the microprocessor. Then the types of semiconductor memory, that is RAM and ROM, read-only memory and random access memory. Then for read-only memory is this is the type of data that is stored permanently in a computer. Then for the random access memory, it can be directly accessible by the microprocessor and it is temporarily stored on the computer. Then over the years, there has been an evolution of the Intel microprocessors, and this goes down from this brings us to Intel x86 architecture, which is introduced. The Intel x86 architecture was introduced with the Intel's legendary 8086 processor, a cheaper variant of which was the 8088 that powered the IBM's equally legendary personal computer in 1981. The success of the 8086 and 8088 control processing units is what kick-started not only Intel's dominance but also the prevalence of the x86 ISA. AMD first started manufacturing x86 chips for Intel to use in the personal computer, but eventually the Intel tried to cut out AMD out of the picture, which led to a legal battle between the two companies, since they were all fighting for the same thing. Then in 1955, AMD won the right to make its own x86 chips. Then for the ARM architecture, the ARM architecture was introduced in 1985 and developed by Acorn Computers between 1983 and 1985. Hence, the word ARM at first stood for Acorn RISC machine, and then it was later changed to Advanced RISC machine. It represents a different approach to how the hardware of a system is designed compared to the more familiar server architectures like x86. The ARM develops ISAs and licenses them to other companies who build the physical devices that use the instruction set. Then, as I conclude, in my view, according to how I've seen and researched and read about the history and development of computers, in conclusion, I'd say each generation and upgrade of these computers is characterized by greater processing performance, large memory capacity, and generally smaller size than the previous one, from generation to generation and then from upgrade to upgrade. Thank you, that's all I had.